Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. Today we will continue making this awesome debugger, and if you'd like to follow along, please don't hesitate and be welcome. If you have any questions, you can post them on Twitter or YouTube, and I'll be there to answer. With that said, I would like to start by opening the project, which I already opened, and let's compile this. Since it's been a while since we did something with this, I would like to remember by running the exe, which we have here. And we have it good, we have it running. Everything's nice and clean. We have our string being decoded as we left it in the last time. So yeah, so what I remember was that we were playing around with the specification of it, which is this file here, which we define it such that we're trying to define the rules that the specification gave us, as a bunch of tables and stuff like that. And that's the last thing we did, and as long we also made this language specification where we were trying to define a better way. And in fact, it's not just like a better way, but just like a more, let's say we can say a simpler way to represent it, and this is just for us to say, like, we already have a representation for it, and I think I already explained this, but it's good to remember because it's since we left off, it's easy to forget this stuff. So we have this call here that's called this data structure that we call EagleFly mnemonic entry, which pretty much serves as this is all the data information that we need to interpret and identify an instruction. So each instruction has its own mnemonic entry in most of the cases, and it's each of all of these ones all of those this is all the information that we use right now, that the disassembler uses to interpret the data, the code, the opcode bytes and stuff like that. So that's good. And the main reason to start doing this kind of stuff was that we were trying to think, like, hey, when we start, like, wait, let me open it. Yeah, right here. Right here. Here you go. If you see, we have all this craziness going on here, where even though it's kind of simple, just seeing, like, each entry, it's a little one different. A disassembler has this with the usage code, and doing the disassembler as simple as possible, as we've been doing right now. It's just like we found that we have a lot of entries. We have a lot of entries, and we want to manage them in a way that makes sense. That's the whole problem. We want to manage them, and to have the problem comes, like, one, we want to have an easier way to add new entries. That's the first thing. Two, we want to have a nice and simple way to modify those entries. A way that we can understand, a way that another person could understand if he wants to modify it. Imagine, like, in that case, we want somebody else to somebody that is external to the user application, that is the disassembler, and it's like, now we have new entries. Probably we could add it. Probably, I don't know, but it could be another one, it could be ourselves, who knows. But the purpose is, like, for purposes of maintainability, we want to have a way to modify the entries easily, add new entries as we need, erase entries if we need, because specifications normally sometimes throw out instructions, and they bring new instructions as well. So it's a fluid system. We want to have that kind of capability and functionality, so that it's just simpler for us, and for the sake of it, like we started to think about that, and we came with this kind of idea where we were, thanks to Mr. Alistair Ray, and thanks God, like we were we found out, like, well, we this kind of a specification is just super simple, in the sense that it has all the encoding fields, the bit fields, bit vector, for the instruction that we want to code, and it has the assembler template. So this is all we need to disassemble one instruction. So the nice thing about this representation is that somebody that doesn't know this data structure that we have here, which, I mean, to be honest, is nobody should care about this data structure presentation. We do, because this is the data structure that the disassembler uses. But for the purposes of a user adding new instructions, modifying instructions, this is the data presentation that he wants to see and that he understands, because this is something that he can go and look to the specification itself. These has symbols that the specification defines, EV, HV, and stuff like that. T, D, W, mod, rect, RM. All this stuff is something that is inside the specification. So somebody that at least that has seen or has read the specification should know that what it's looking at, And probably, I mean, probably it needs something more, but I mean, at least for the basics, it's just this. And we can just represent all this stuff just in a set of instructions, and we as the programmers of this, we can try to translate this stuff to this, so that the disassembler can use, and we have to see like how useful this is going to be. But in the whole sense, we want to have that, especially now that we are like adding more and more entries to here. We don't want to have a mess where we don't understand like what's going on, which is one, which is the other. We want to have like a clear system of which instruction it is, or how we can just easily find an instruction. That's probably another interesting problem there. Like how to find an instruction stream. That's and at least, I mean, that's something that we can find. Probably with this thing, in the encodings themselves, we find that I mean, this is just this, I mean, we just copy pasted. If you've seen the the previous videos, you see me like I just copy pasted these values and I just put them right there. So it's not like super difficult to see that the thing has been taken out from the specification and just put it right there. So and it's just like just for us to make sense, like we want to copy the specification, we just want to make the disassembler read the data values from the specification, translate it probably to intermediate thing that we already have, that is this, and just use that to disassemble any instruction that we may want. So yeah, that's the whole story, and today we will continue with that. And the thing that I was this is important because we were just trying new stuff and stuff. We were doing this stuff, and probably, I mean, this is not at all probably useful for us, because if you think about it, well, all this stuff we already do it. We are already doing it, so it's not like super relevant to keep this stuff. So I think I'm gonna just erase it. It was nice to have it, but for basic zero, it's just, oh my god, oh no, right here. It's not the thing that we need. we just need this stuff, and that's it. So yeah, so one thing I would like to do here is like, well, right now we just have this add instruction, which is the first one. Well, is this one right here. So I want to do this stuff. I want to start by saying that first we're gonna start by doing all the instructions that we have in this forum, in this data format. And once we have all of them, we're gonna start to do the table translator. That's the last thing we have, so that we can see at least, since this is like the usage code here, we want to see the usage code here first, so we can see like, oh, we can just represent all the instructions as we might want, and then we can have a nice thing where we can just try to translate all the stuff to the thing we want, and that's it. So I would like to continue with that, and I would like to say, well, right now I have we have, well, the nice thing is that we have from different groups, so we can start by that. Oh my god, no. So and for being more, we can call it like this. There you go. And we have this one. So we can just start by So there you go. These are all the tables that we use right now. 1, 2, 3, 4, 6. So we have 1, 2, 3, 4, 5, 6. There you go. And most of them are from the 1 by table, so that's okay. So we have 10, 11, 12, 13, 16, 18, 19 entries right now, which if we go to the disassembly, no, over here we can say, I don't know how many there are, 1 2 3 4 5 6 7 8 9 10 13 14 15 16 17 18 19 20 21 22 23 24 25 26. So yeah, that's okay. We have more than we disassemble more instructions because we disassemble repetitive instructions like these ones, but with different addressing modes. For example, the move one is more clear. So this is the same mnemonic, mnemonic entry, but it has different addressing modes, and that's the reason why they are more. So that's okay. That's normal, So we cannot use this to to interpret the entries. We have to use the mnemonic entries themselves, So we have to have a way to to say, well, to remember which were the ones and stuff. But I don't think it's gonna be too hard to do that. The whole thing of it is just to have this kind of thing, for each one. So we have already the first one, which is the add entry. We have the we have the one that goes on the other way around, which has a D bit not set, so it goes from AB GB, from GB EB. That makes sense. So it goes from, I believe, from register to memory, or goes from register to memory. So it goes from register to memory. You can leave it like that. That's okay. We have a conditional code. I don't know why we did that one, but we can leave it like there. It doesn't matter. So the next one will be this AAD entry. So let's go and find it out. We can find it on the dsystem. Probably that's good. And that's AAD is, where's it? Oh, we didn't disassemble it. It's because it's a 32-bit. Is it one? It's a 32-bit, so we don't use it right now. But in the case where we wanted to, we don't use it right now, but because we only disassemble 64-bit instructions. But well, I'm gonna pass it by. So the bound is also a 32-bit instruction, so it's not gonna be there on the output stream. So we can just pass it as well. So let's go to the move 001. All the move instructions. So this move 00, and and the important part here is like I want to find a way to not to look the specification all the time that we are looking at this, and that's kind of hard, because I mean, if you've seen, I mean, the way that we've been looking at this, it's like, oh, we have to go and make a tedious search for all instructions, seeing how they are the specification. It's kind of nonsense in that sense. Like we have to go and look and read it. That doesn't make any sense at all. We there's a better way to do it, and that better way should be like to have a machine readable specification. But that's not the thing, so we have to just use it as it is. So I would like to go to the move instruction. Does that make sense? Move instruction. Okay, so we have the move instruction here. So let's find the one that we are looking for, and let me put also here the move. Well, let me first find it here. So the first one is has some modern person, rectangle RAM, operand count 2, register operand size. It has a data size B. Data size B. What's data size B mean? I don't remember. Let me see. It's right here. It's 1 to 15, and is it one of the weird ones that we have here? Probably it is, isn't it? Yeah. It's like, what's going on here? So yeah, it's a World War chord. Okay. It's a World War or chord type. Okay, cool. So that's good. So that means that we have to find the opcode byte for that case. So it's gonna be, yeah, because it's simpler with the opcode byte, I guess, because with this thing it's just not a thing. It's valid on 64 and 32-bit as well, you know, so that's good. But let's see, we have to count this thing. So let me, it's 1 2 3 4, it's the 4, okay. So it has to be the 4. 1 2 3 4. 0x0089 is encoding. So we have an 89 thing. Nice. So we have this one here, and we have, I believe, one that it's valid on both, which is the 32-bit one. Well, probably not. Probably we are, yeah, because he has the RX here, but the RX, it's just, I mean, in the way we have it right now, it's just like we already do that thing as well, so it doesn't matter. So we have this one and this one. This is not valid. Oh, this is valid for 64-bit. That's kind of nice. Normally 16-bit encodings are not useful, are not possible on 64-bit mode, but this is possible. So, well, that's it. So move RM6 16 16. It's just the same case here. So we have all the encodings for that in case. So, and that's okay, because if you remember, it's World War chord. That's the types, you know, data types that we have here. So that's okay. We need an REX prefix for doing that kind of expansion, but that's okay. So we have this instruction right here. This is not encodable on 32-bit mode. That makes sense because it's 32-bit, and that's it. So yeah, okay. So we have these encodings. So if we go to the 89, we can just find it on the encodings themselves, you know, right here. And right here, I'm gonna I'm gonna go for the move, which should be right here, and we have data, and we have 89. So this is an 8, and this is it should be this one, because it's, well, it can be 88 or 89. So if we're looking at these two right here, right here, they have the same encoding, or well, they respect the same encoding. So it's just that we have a bunch of assembler instructions that match to one instruction, to a binary instruction. So we have a lot of that kind of cases where the representation doesn't match one instruction. So that's important because it's not a one-to-one thing. It's not like saying, oh, we have this assembler instruction and we have another way, we have that's something important that we haven't thought about first. Is like one encoding serves multiple translations of the assembler language, and choosing which translation of assembly language to choose depends on the context that we happen to have in that moment. So doing this kind of stuff where we have right now, we have like a one-to-one thing most of the cases, and saying most of the cases because we don't think about we don't think about the encoding. We think about the assembly, and I don't know if we can just skip the encoding of the encoding. Probably not. I mean, it doesn't make. I mean, at first glance, it's just saying like, well, it's like it doesn't make sense at all because how to say. I was like, all these instructions are the same encoding. There is not the same, of course, because one it has one bit set and the other doesn't have that bit set. So yeah, I mean that's understandable. But in the entry itself, we just have one entry. So I mean that's not a huge deal. It's just like, well, that's gonna be the case for that case, but for that matter, that makes sense. So it's just like me saying, well, I'm gonna pick the move instruction that is from register 1 to register 2, or from register 2 to register 1. It all depends. But this is 8 3. It's it's a 10, so it's an 8. It can be an A or a B. So this is the next pair, which is this one. All these things right here, and the only difference here is just that is register memory, register memory, register memory, register memory, and this is memory register, memory register, memory register, memory register. Register memory, register memory, register memory. And right now we have the ones is register memory, register memory. Well, memory register. So we have one move. Most of the moves here are memory register, isn't it? We don't have a move. Well, probably one of those can be. For example, this is register register, which was the first one that we did. If register register, register memory, register memory. then okay, so yeah, I mean, I was just like thinking, well, so how can we do that thing? So that's okay. That's okay. Mm, my thing would be like, well, because if we are thinking on the assembly representation, well, this is assembly representation, but one thing to think about is just like, well, we have different assembly representations here, so it's not just like saying me here on the spec file, oh, you have one direct translation. um you probably do, I mean, because this is not like direct in that sense, because ev is not as this. I mean, ev is just telling me that, oh, we have a something that it's word or core. We have all the representations that we have here depending on the addressing mode and or the operand size. The operand size or the effective address size, whatever. Both of them are important, but yeah. So we don't care about this. We are gonna care this later, but it's important to have it just for for the sake of it. So the thing that we care more is, where is it? Right here. Let me go and find the move. The 89 there. Where is it? 1 byte. 80. 89. Here you go. So we have a move EBGB. That's what we care about. So let's add that thing. We're gonna add it right here, and we're gonna say move EVGV and one of the nice things is that, well, now that we know that we have to have different representations for the same machine representation, is that makes this the generator for this, because from here we can just generate all the possibilities to this, and we will have all of them to give the match. You know what I mean? If that makes sense. So that I mean, before we were like thinking, oh, so how are we gonna do for having repetitive? I mean, before, well, the only thing that we care about is just like, well, the data size was depending on the operand size thing, we just make the translation for that. But it's a nice question. Because right here we don't make that difference at all. When you're here, we are just thinking about the byte. We are just thinking about this. The 89. So this thing matches the 89. That's it. So this is more like not mnemonic entry, but how you called it, the opbyte ID entry, like the thing we have here, this thing here, because what it matches is the opbyte ID. That's it. It doesn't match the mnemonic. It doesn't match anymore. Well, it matches, the thing that it matches a mnemonic is just consequential, but the thing that it really matches, or the thing that it's constructed from, is from the opbyte ID. So I'm gonna put it to do there. I'm not gonna change it right now, but I'm gonna put it here to do here. These are not mnemonic entries. Really, they are up by ID entries. Oh, my bad. These are not mnemonic entries. So yeah, they are not mnemonic entries by real. The thing that we have a mnemonic for that is just trivial. But the thing that we care about here, or the reason why we have it, is because it matches directly to one op by ID. So that when we find an op by ID, we just can't find trivially the entry that it matches to. That's all we want from these things, from this representation. So that's the reason we had a problem. Like, well, so how do we find the type? But that's something that we defer to the real place where we really want to make that notion, or to make that difference, which is on the place where we are just pushing the thing. Like, where do we want to know which type it is, or which type size it is? It's just onto the last step where we say, well, which is the context here, which is the effective operand size or effective address size. Right there is where we just ask the question, well, which is the effective operand size? Is this a type that is affected by the effectiveness of an operand size thing, by the context? If it is, we just modify it. If it's not, we just keep it by. So we have those different rules. Some of them are for, some of them are not, some of them. But that's something that just the disassembler cares about. We don't care as the entries themselves, and in the entry itself, he doesn't care at all. We just push it as the V, and that's it. So it's not like, well, we have a direct translation for it. We have a B here, so we put a B here as well. So yeah, so that's not gonna be the thing. I mean, that's not gonna be the, how to say, I'm just having an interesting thought. What I was thinking about, I was just bear with me. This is new to me, it doesn't matter. But the problem the real problem that we have here is just that, if you remember, we, just for the sake of, at least we thought that it was faster just to check on the IDs and just keep the entries being statically, just fetch when they were needed. It's just like, well, that's most of the time that's the important case. But we just have to have a way to keep the ID near to the entry. It's just like me saying, well, probably this has the ID, where is it? No, this is not. It's just like me saying something like this. Dun 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 dun. Well, I'm not gonna. Well, I can do the Well, I'm gonna do the first one for the sake of it. It's just like me saying this, add entry of by ID, and I say OX. What was the thing? 03. I guess, I don't know. But it's just something like this, It's just like, well, I can just see, it doesn't matter. Yeah, it's 03. Okay. So we have 03, or even better, just copy this. We have that, and then we just say, well, we have the O3 thing there. We already have a way to go and look at, and just to make sure, well, we have the O3 from the one bio table, and that's where is it? Dun, 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 dun. That's this. Where is it? Where is it? Yeah, this one. We have the GVV whatever thing. So so that's it. We have GVV because we found it there. We don't care about the encoding at all. We just have a thing that just tells me that. And that's it. So I mean, this is all we need. We just have a way to match it to an ID, because that was the whole problem with it. And I mean, this is not gonna be looked for or any, probably it's not. We can just keep it that way. It's not like we are gonna keep it. We can just have it as an extra thing just for the sake of it, or we can just use it to match it. It doesn't matter. The whole thing is that we want to see which one it is, so that if I say this, I want to copy this, say like that. This is the add. This is the D5. Let me make sure D5. Yeah, it's this one. It's the add. It's I64. That means that it's not a 64-bit instruction. It's not possible in 64-bit mode. That's cool. We have an IB there. So yeah, so we have D5. What else here? We have bound, and then we have 62, and then we have 89. There we go, and this is some move. Blah blah blah. And this is an 8B. I was like thinking, well, we can just say that instead of calling this 01, because that's nonsense, we can just say 8b, and all of them can be called 8b, and that's all. So we have so it's more like saying, well, what's the name of this or something. So it's just like I don't know if we want to do that. I mean, it can be something like this: add this, and that's it. Add 003, add 003, and I can keep this just for the case, but and this is an add 005, add 005, and this is bound 0062, bound 0062, and then we have a move 0089, which makes more sense than the thing we had before. Move 0089, and then we have 008b, move 008b, okay. And what else can I say? I mean, this is the same. I mean, we're gonna do the same stuff here, but I was just like, well, let's continue, whatever. So we have move blah 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 blah, and then I'm gonna have this thing move 02 entry. This is gonna be 8a, there you go. And this is a push, which is a 15. And this is but I did, and this is gonna be called push 050. this is the other push, which is a 54. So this is a 54. And this is gonna be push 0054. There we go. Then we have a jump entry, which is an EB. And this is down, and this is a jump OOEB, and oh my god, this is the jump, the E9. Hold on a second.
¿Están tus camisetas?
Yes.
¿Ya quieres comer?
Sí.
¿Cuántas quieres? Limonada.
So this is E9. Yes, E9. Oh no. No. So this is the E9, and that's okay. Now the shift left is a 2-byte thing, and we have all this stuff joined together, and the shift left is this one. We just have one. Now this is a p-line entry. So we have here a repeated one and then another table, so that's okay. So we have in resume, now these are abstention table entries. That means that the value comes on the mother and byte as well, you know. But I was just trying to remember. Well, it doesn't matter. I mean, it's just the same, but we found out that we just need that, but that's okay. Well, we're just gonna continue with this. It's just super simple thing that we're just doing right now. And we have a near absolute here. Well, we don't need to know that. We don't care about that. It's just like whatever. We can just find it out later. We just want to have a way. Well, I'm gonna continue. Jump near absolute. It's gonna be this 20ff. That's correct. And this is gonna be the opcode ID. And this is a jump to this, and this is a jump to this. Go jump 20ff, 28ff. It's another jump. So I can just say, you know, I'm gonna say that, and this is, oh my god, there we go, 28ff, and this is gonna be jump 28ff. There you go. and then we are on the FLD, which is floating point instructions, which is correct. FLD, okay, so if we compile this, I don't know if it's gonna compile, but let's see. And now the only thing we need to do is just to add here and there you go. So if we run this, everything should be the same. We haven't done anything at all that modifies the instruction stream at all, or well, the way it disassembles it. We we just wanted to add an extra layer of information for us to understand the IDs. And if you see here, I mean, this is simpler for us to see. I mean, this is like the first stage, it was like, I mean, the problem was that the readability of it. So I just say, well, why not to just add some extra stuff just to give it a match, even though we just don't match it with this. And probably, I mean, I can say here that note Alex, this is only for readability. We make the match based on a positioning system. Well, actually, it's not a positioning system. We have an ID, isn't it? We have the ID and the entry index. So, which, I mean, in the case that it's just the same position, it's just because that's the way we chose it to do it. But and that would make this unnecessary at all, But well, it's necessary because yeah, it's we have to keep it somehow, because we just because we added one table, then the other table, and it's just that linear thing that we did. But I mean, that's the case, it's not like super difficult. I mean, that's not something that we need to change at all. That's good. It's the simplest thing possible that we thought about it. Like, well, we just have a bunch of tables joined together in a one big table when you just divide it into groups, and that's it. Like we don't need anything else. It's just like that's all we need, and that's the way we are doing it right now. So for the case of readability, yeah, this is nice. Now we know that we have the 8B disassembly. We have that. We all have data size information that we use. In the case we need something else, we can add it here, but that's it. So I think that's nice. That's at least it's a simple change, super simple, nothing fancy there. But it's useful. We know now that we don't have to go and look for the old byte IDs. We already seen it here. So that's nice. Okay, so I think with that, I mean, I don't know you guys, but I think we can continue with that in that way. I mean, it's not. We can make. I mean, we already know that. I mean, we're starting with the first soap bag thing, so that's okay. So I think, I mean, the next step will be just to continue disassembling the other stuff. Just the same the same way we are doing it right now. And we can keep it that way. What is the one by thing? We can just add and add and add all of those, add all of these ones, in the same way. Like disassemble all the outputs and just go serially. I mean, there's no reason why not to do it. We just care about doing all of them, and that's it. So yeah. So I don't know which is the next one. So I think I'm gonna stop here because we already left. The time is over for this. But now we have we found out that this is all the thing we needed for the reliability problem. That we just need to clean up the entries and have a system to see which is the ID that we are looking for and the stuff. The other problems, I mean, the other thing is about this is not that. I mean, this is an abstract meaning. that probably, I mean, that's not a problem, but we can think about that later, if that makes sense. And probably it's not gonna be a problem at all. So yeah. So at least, I mean, having a way to count the instructions that we are already disassembling, that's fine, you know. So now we can say, oh, we have this one, we have this one, we have this one, we have this one, and that's all nice. So we can just check. We can just check all the instructions that we are already disassembling, and we just add more to the list. That's it. So I think that's it. Mm, uh, I'm gonna stop here, but please, if you have any questions, post them on Twitter or YouTube, and I'll be there to answer. Yeah. Please, you can post them on Handmade Network. Well, yeah. And yeah. So thank you very much for coming, and I will see you all on the next stream.